Alright, so we're going to go ahead and get started with the general derivatives notes. So some formulas from pre-calculus. I'm going to tell you right now that you in no way, shape, or form need to have these memorized. So what I would do is I would Google them. So this is basically, you can Google cosine of x plus h and it'll give you like 5 million formulas that you could write down. But we only need one of them. So what we would do is we would write cosine x, cosine h, minus sine x, sine h. So I'm not expecting you at all to have this memorized. We're just going to use it so that we can prove a couple of things a little bit later on. And then we're going to do the same exact thing with sine x plus h. I'm going to look that up. So that gives me sine x cosine h plus cosine x sine h. Again, I'm absolutely not expecting you to memorize these at all. Now for the recall part, this part we should actually remember because we just did it. So the sine h over h is equal to 1, and then the cosine property is just equal to 0. Okay? So the way that I remember it is sine has an I in it, so that's a 1, and cosine has a 0, so it's 0. Now, I'm not going to fill out this part right now, the derivatives of the basic trig functions, because that's basically what we're going to prove in this next section, and I know that it's on your notes in a different order. Okay? So, what we have here, I'm going to pause for just a second. Alright, so what I'm going to tell you right now is that we're going to use the limit definition to find the derivatives of the following. I decided to put a box over these because it takes quite a bit of writing, and writing on the tablet here is not quite as easy as I would need it to be because you have to write very small. So, what we're going to do is start by writing the limit definition. So the limit definition basically says the limit as h approaches 0 of f of x plus h minus f of x over h. Now this is something we should know because we just took a quiz on it. But we're going to go through and plug it into sine. So our sine function will then say sine of x plus h minus sine of x all over h. Because remember, we're just plugging x plus h into our function and then just subtracting our function, which is sine x. And now we see why we wrote down sine of x plus h earlier in the notes, because we're going to use it right here. So I'm going to use my formula and rewrite it. It's going to be kind of long here. So notice all I did here was rewrite. So I did sine x cosine h plus cosine x sine h. And I'm going through and I'm just rewriting. Now when you're doing proofs, you have to learn to get a little bit fancy in the way that you write things. So what we're going to do here is we're actually going to reorder the way that the terms are listed on the top. Because if you'll notice, this part right here, the first part, and the last part both have sine x in them. So we're going to use that to be kind of fancy in the way that we do things. So we're going to reorder them right here. So we reordered them. Notice we have sine x cosine h minus sine x plus cosine x sine h. Now if you'll notice what I did is I kind of put a little pink divider line on here because what you're going to do is you're going to separate it into two parts. So when you add two functions and you take the limit of them, you could do them separately and then add them. Okay? So that's what we're going to do here. We're going to rewrite them as separate things. So you're going to have the first half being sine x cosine h minus sine x all over h. And then you're going to have the second half being cosine x sine h over h. So here I have them rewritten. Now you might ask, why in the world would we want to do that? So the main reason is when you get to this step right here, you should notice that over here, so let's look. So over here, this part right here, we've got sine x over, or I'm sorry, sine h over h, which is exactly what we were hoping for. And on the left side, you can factor out a sine. So if you factor out a sine, we'll see one of our other properties. So I'll slide down and we'll look at that. Oops. Oh man. All right. And we'll slide down. Notice here I've shown that we factor out sine, and then we have cosine h minus 1, and we have sine h over h, and I've boxed them both because they both are specific properties that we've learned. Okay, so cosine h minus 1 over h is 0, and sine h over h is 1. So what we're going to do is we're going to replace both of those things with 0 and 1 accordingly. And notice I've written that sine x times 0. Anything times 0 gets you 0. And then we have the limit as h approaches 0 of cosine x minus 1. Now when we evaluate the limit, what we do is we go through and we plug in 0 for h. But notice in my function there is no h. We just have x, which means that all you're left with is x. So we have 0 plus cosine x, which means that the derivative of sine x is cosine x. And that's exactly what this says. This notation here, remember, this notation here just means derivative, okay? D dx of sine x, okay? So the one right beside it is going to be almost identical, but using the other property. So what I'm going to do is I'm going to go through and I'll show you the first two steps, and then I'll ask you to pause it so that you can reorder and you can factor out. So the first two steps would be to write the limit definition, and then to plug in cosine, and then rewrite using your formula. Alright, so go ahead and press pause and I'll do the same. And then what we're going to do is we're going to go through and match them. So you'll check yours with mine. And there we go. Okay? Alright, now I'm going to go back and make sure we write down the derivatives because I know that that's underneath yours. So right here we have our basic trig functions. We just proved, and we should technically not write it like this. It should be d dx. That's the derivative of sine x. The derivative of sine x is cosine x. We just did that. And then we have the derivative of cosine x is negative sine x. That's what we just wrote. And then we have, now this one we actually did not go through and prove because for some reason Ms. Wise decided to put it here when it really goes in the quotient section, which we're about to learn. But that's okay. So the derivative of the tangent is secant squared x. Okay? So if they ask you for the derivative of tangent, you just replace it with secant squared x. Now we have a couple of other derivatives. So these derivatives, it says, are the natural log and exponential functions. So what it says is that the derivative of e to the x is the only function that has itself as a derivative. So basically what it's saying is the derivative of e to the x is e to the x. So really you don't have much work to do at all. Alright? So if they ask you for the derivative of e to the x, you get to state just the same exact thing. Now they ask you what the derivative of the natural log of x is. So the derivative of the natural log of x is going to be 1 over x. Okay? Now, what we're going to do is we're going to practice with our natural log properties in order to do the next couple. So it says use the laws of logarithms to find the derivatives of the following. So the one thing that you have to remember in order to do these is how your exponents work, how multiplication works, and division works. Because we're going to try to separate it. You have to always get ln x alone. So this is ln x cubed, so we need to move our 3 to the front. That means f of x equals 3 ln x. You don't need the parentheses, but I'm putting it there to explain to you that ln x must be alone, and as of this stage, ln x is alone. Okay? So now we're going to take the derivative. The derivative is 3 times, what is the derivative of natural log of x? Oh yeah, right here, 1 over x. That means that the final answer is f prime of x equals 3 over x. And that's all. Okay? Now we're going to do the same thing here, except this one takes a little bit more work because we have multiplication. So when we go to expand, multiplication becomes addition. So ln x plus ln e to the x. Oh, I forgot my squared. Okay, so now we have one more step. So g of x equals, remember exponents come to the front. We have 2 ln x plus x ln e. Now the one thing that you might have forgotten, but I hope not, is that natural log and e are opposites. So because they're opposites, they cancel each other out here. Okay, they cancel each other out. So what we're going to do is just take the derivative of, so g of x is actually 2 ln x plus x. And now we just take the derivative. So the derivative, g prime of x, is 2 over x plus 1. Because remember the derivative of x we did last class, it's just the power rule. Okay? Now here we have ln x minus 1 over x. All we need to do here is rewrite. Then we can easily do the derivative. h of x equals ln x minus x to the negative 1. Okay? Now we're going to go through and just follow the exact rules that we've been working on. H prime of x equals 1 over x plus 1x to the negative 2. So I'll rewrite that. H prime of x equals 1 over x plus 1 over x squared. Okay? Perfect. We can leave it just like that. Alright, now we're going to rewrite the next one. So y equals the natural log of 2e to the x minus the natural log of 3x. Because remember, division means to subtract when you expand. And we're going to go through and expand it just a little bit more. So we're going to write y equals, and we're going to expand it, the natural log of 2 plus the natural log of e to the x minus the natural log of 3 minus the natural log of x. Because these were both being subtracted, so I needed to make sure to subtract them both so they would have been on the bottom originally. Okay? Now, you guys get really nervous here, but the natural log of 2 is just a number. Just a number, no need to freak out, so it goes away. Now, the natural log and e cancel each other out. So then we just have x. So the derivative of x is 1. Natural log of 3 is just a number. Don't freak out. So it goes to 0. Then the natural log of x, the derivative is 1 over x. Okay? So we have 1 minus 1 over x. And if you need me to, I can write right here that this is really natural log of 2 plus x minus natural log of 3 minus natural log of x. Okay? And then we took the derivative. Alright, now we actually have a couple more. They're hanging out down here. Forgot about that. So, we're going to do the same exact rules. So, f of x, just rewriting, is the natural log of 4 plus 3 natural log of x plus x natural log of e. Oops. Okay, now remember, this part goes away because they're inverses. Now we just need to take the derivative. So the derivative is f prime of x. The derivative of a number or a constant is just 0. So we get 3 over x plus 1. Okay? Now the last one. So the last one you guys get real scared because you have a pi there. But everything is going to be okay. So g of x equals pi e to the x minus x to the negative 2/3. Now remember, pi is just like any other number, so everything is fine. Pi is like any other number. So e to the x, the derivative of e to the x is e to the x. So we have pi e to the x plus 2/3 x to the negative 5/3, and then we just rewrite. So g prime of x equals pi e to the x plus 2 over 3x to the 5/3. Which you can choose to put back into radical form if you'd like, but you absolutely do not have to. Okay? Alrighty, that's all for this lesson.